Hello students, let's solve some of the numericals on tautomerism, some of the advanced JEE level numericals from tautomerism from MS Chauhan, Himanshu Pandey, OP Tandon and Solomon and Fiery and KS Verma. So I'll first let's go first to MS Chauhan. What are the numericals on tautomerism given? The first numerical on tautomerism given is question number 98. The maximum enol content will be in which one of the following compounds? These are the options A, B, C, and D. The option which is correct is D option, because the hydrogen will migrate from the activated carbon here, and it will form OH, and double bond will come here, and it will be stabilized, one by hydrogen bonding, second the two phenyl rings will stabilize it with resonance. So this is the most stable enolic form, because it is stabilized by two, things. It is stabilized by a double bond, and it is stabilized by two phenyl groups. So this group will have maximum enol content. See, the second will also have a good enol content, but it's only stabilized by hydrogen bonding. And this fourth is the correct option, because it's stabilized both by hydrogen bonding and it is stabilized both by resonance. So fourth is the correct option. So fourth will have the maximum enol content. See, enol content depends on a lot of factors. The first factor is hydrogen bonding. The second factor is aromatic nature. The third factor is resonance. The fourth factor is nature of solvent. And the fifth factor is the strain. For example, question number 100 is on strain. Which one of the following, what is the decreasing order of enol content? Which will have minimum value of enol content? The third will have minimum value of enol content because of angle strain. The first will have maximum. See, the enol content, hydrogen will shift from here or here, the double bond will come here and it will form OH here, and it will be stabilized by hydrogen bonding. Here also the alpha hydrogen will get shifted from here and it will form OH, and it will get stabilized by hydrogen bonding. Here also the hydrogen will get shifted from here and it will form OH, and double bond will come here and it will be stabilized by hydrogen bonding. But the thing is that hydrogen bonding will be in all the three compounds, but the thing is that the angle strain will be less in the first structure, so it will have maximum enol content. The third will have maximum angle strain, and it will have minimum enol content. Angle strain plays one of the most important role in keto-enol isomerism and content and enol content. Question number 106. It's again on the enol, which will give the maximum enol content. I told you the factors affecting the enol content. See, here also hydrogen can get shifted here and it can form an hydrogen bond. Here also hydrogen bond will be formed, but there will be two factors in this question. When OH will be formed, it will be stabilized by hydrogen bonding, and it will be stabilized by the two phenyl rings. It will be stabilized by C6H5. So this option will give, because there are two advantages of increased enol content in this. One is hydrogen bonding, and second is resonance, which will be exhibited by these rings. Now, coming to question number 107, which one of the following will give unstable enol content? See, in this question the options are like this. See, in third option, once the hydrogen gets migrated from this position, it will form a structure like this, which will be anti-aromatic because of presence of pi electron. See, there are two double bonds which are placed at the adjacent position, and it will make it an anti-aromatic substance. The stability of enol content is that aromatic will be more stable, followed by non-aromatic, followed by anti-aromatic. This will never give an enol form. This compound will never give an enol, because its enol form will be an anti-aromatic substance. It will be an anti-aromatic substances never give. This is the frequently asked question in both Himanshu Pandey, MS Chauhan, KS Verma, and in OP Tandon. This question, please note that this question frequently, because its enol form will be like this, and there will be two double bonds. There will be an OH, and the compound is anti-aromatic. So this will never give an enol form. This will always give an unstable enol form. These all will give a stable enol form. See, hydrogen will be shifted from here. It it will become OH. But here it will give an anti-aromatic compound, and anti-aromatic compounds are highly unstable, and anti-aromatic compounds are highly unstable. Now coming to question number this question number 126. The tautomer of second compound is the tautomer of second compound is the tautomer of this compound is the tautomer of this compound can be both this and this compound. See here, the hydrogens cannot shift from this and this position. The hydrogens have to get shifted from this position, because hydrogens with sp2 hybridization will not participate in the tautomerism. This is a classical example of para-tautomerism. The hydrogens have to shift from here. It's not necessary that alpha hydrogens will shift. The hydrogens can shift from here, and it will also give a keto form, like it will also give its enol form like this. And here also the hydrogens can shift from here. This type of tautomerism is called alpha tautomerism. So the answer for this question is both first and third. Both first and third. Again, this question is also based on the same thing. Where from usually the hydrogen will get shifted, whether it's alpha hydrogen, whether it's beta hydrogen, whether it's gamma hydrogen. Usually there are two double bonds here, so this hydrogen and this hydrogen will never participate in tautomerism. The hydrogen which will participate in tautomerism is this gamma hydrogen, and it's a classical case of para-tautomerism, and the structure will be like this. Here OH will come, and it will be substituted by three double bonds. The hydrogens which are at alpha and will at beta positions will not transfer. So in the enolization of the given molecule, the hydrogen which is involved is gamma hydrogen. So third option is the correct. Here, the hydrogens which are present at a double bond never participate in the tautomerism, although they are alpha hydrogens. So the preference will be given to the gamma hydrogen in this case. So the answer for this question is third. Now coming to question number 128. Among which one of the following given structure exhibits tautomerism? See, the first structure can never exhibit tautomerism. The reason for that is when the hydrogen will shift, when the alpha hydrogen will shift from here, it will form a compound like this. When it will form a compound like this, the double bonds will be at cumulative positions. So this structure never ever exhibits tautomerism, because its enol form is highly unstable due to the cumulative positions of double bond. In this is the second answer. Which is likely to get tautomerism. The first option will never exhibit tautomerism. The two structures, I'll recall it, the two structures which will never exhibit tautomerism or will never have an unstable enol form is this structure, because it forms an anti-aromatic compound, and this compound, because the enolic compound which it forms has double bonds at a cumulative position, not at an alternate position. Whenever double bonds are at cumulative positions, they will form an enolic form which is highly unstable. Mostly frequently asked question in Himanshu Pandey, mostly frequently asked question in MS Chauhan, most frequently asked questions in Solomon Fiery, most frequently asked these two questions. You have to always remember these two structures. They will never participate in tautomerism, because in first structure an anti-aromatic compound will be formed. In this compound, the compound which will be formed is that double bonds are at cumulative position. Whenever in alkene the double bonds are at cumulative positions, cumulative means they are close to each other, they are very close to each other, it's highly unstable. Now coming to question number 131, which is on Bread's rule. Among which one of the following, coming to question number 135, which is on Bread's rule. See, among given ketones which does not analyze. See, in Bread's rule we have to remember one thing. This carbon, which is a bridgehead carbon and is present in sp3 hybridization, will never migrate its hydrogen to this. See, in bicyclic bridgehead compounds, the structures are like this. these hydrogens will never migrate. These are called bridgehead hydrogens, and they never participate in tautomerism. This is Brett's rule, because they are in sp3 hybridization. Once if they will migrate, if the hydrogen will migrate, they will form an unstable structure. So in this structure, see here the carbon cannot migrate because it's a bridgehead carbon, it's in sp3 hybridization. So usually the carbon, but on here alpha hydrogens can migrate. Here also, in this case, once if the alpha hydrogen migrate from here, here there is no alpha hydrogen, if the alpha hydrogens migrate from here, they will make an unstable structure. Because double bond will come here, and it will be an unstable structure. Here, or they can easily migrate. Here also they can migrate from this structure. So among the given ketone which does not analyze is second option, because once bridgehead carbon will give an hydrogen which it never gives, the double bond will come here, and OH will come here, and it will form an unstable structure. Remember, in Brett's rule, we have to remember one thing. It was also asked in NEET 2013 that a bridgehead carbon never participates in tautomerism. Whenever it participates in tautomerism, it gives an unstable structure. See, the unstable structure is like this, which usually a second option, which usually this will give. So the answer for this is second option. Now coming to another question like this, which is usually from, I think, Himanshu Aryan, which is usually from this. So what is the question? It's Himanshu Pandey. What is the question? Which compound has maximum enol content? See, in this case, this will also give an enolic compound with one double bond, because hydrogen will get migrated from here, and here double bond will come here, and it will form an OH. Here also it will give two double bonds. Here it will give one double bond, but this will have maximum enol content because of presence of aromatic nature. So the answer for this is this. Because of arrow here, it will not give an aromatic molecule. Only one side is aromatic, not this side. This is fully an aromatic compound with the presence of alternate double bonds. So this will give a maximum enol content. Now in this question, this is also one of the very good questions for JEE mains or JEE advanced, which will have more enol content among these, which will see the structure number 3 will have maximum enol content, because once their alpha hydrogens will get migrated, they will form the structure like that with three OH groups and three alternate double bonds, which will give it an aromatic nature. Here there will only two double bonds will come, here only single double bond will come when hydrogen will migrate from alpha. So this will have maximum enol content, because the enol content which is formed here has an aromatic nature because of presence of three double bonds at alternate positions whenever this is formed. And I told in a compound like this, the hydro, which I have already discussed, the hydrogens do not migrate from this alpha or beta positions. They usually migrate from gamma positions, which is a classical case of paratautomerism. So the discussion for these questions is that there are three compounds which never exhibit, which this is unstable, because the keto compound for this is the keto compound for the keto compound for this is like this, double bond O. When it gets converted into enol compound, it's anti-aromatic in nature. Remember, so this will never give this compound like this. There is a double bond here, there is a double bond O. This will never give an enolic form. Once it gives an enolic form, it's anti-aromatic in nature. This will never give an enolic form, because once it gives an enolic form, the double bonds are at cumulative position. So this will not give. Third thing you have to remember, students, is that the bridgehead carbon never, according to Brett's rule, never participates in tautomerism. Never, because it's in sp3 hybridization. Once it will go in sp2 hybridization, it will form an unstable structure. So some more questions we'll do on tautomerism. Some of the easy questions which we'll do on tautomerism are like this. Yeah, which of the following compounds will give tautomerism? So see, we have to generally check for alpha carbon and alpha hydrogens. There are three alpha hydrogens, so this compound will give tautomerism. This compound will also give tautomerism. There are 3 plus 3, there are 6 alpha hydrogens, so this compound will also give tautomerism. Now coming to this compound, this will also give, because there are 3 alpha hydrogens and 2 alpha hydrogens. Here also this will give, because this does not have an alpha hydrogen on this side, but this has an alpha hydrogen on this side. This will also give, because alpha hydrogens will migrate from here, or alpha hydrogen can migrate from this position. Here also this compound will not give formaldehyde. It will not give, because it does not have alpha hydrogens. They are not attached to carbon, so this compound will never give tautomerism. Now coming to this compound also will not give alpha hydrogen. This will not give, this does not have an alpha hydrogen, and this compound, note down, it's very important, this compound will not participate in tautomerism. This compound will participate. It has alpha hydrogen. The alpha hydrogens can migrate from this position. From this side it does not have an alpha hydrogen. This again, this is a very important compound with 2 phenyl rings. It will not participate in tautomerism. It will not participate in tautomerism. And this compound can participate here, because alpha hydrogens can get migrated from here, and it will give an excellent enol form. It will give an excellent enol form. So in guys, the question and in NEET can come about alpha hydrogens. What you have to identify the compound which usually gives an enol form, So here are some of the examples, where I have given which are the compounds which can participate in the tautomerism. It's very important for students to solve these type of questions, and to check the presence of alpha hydrogens, and to solve the advanced level numericals from MS Chauhan, Himanshu Pandey, then Solomon Fiery. He can go through all these questions of the tautomerism. KS Verma, one of the very good books, Engage series, and from OP Tandon. All type of questions are given in tautomerism of both basic, elementary, and advanced levels. Thank you.